Hello, my name's Edwin. I'm a third-year CS major and I use he, him pronouns. The top two courses I like to ULA for are CS24 with Professor Mirza and CS111 with Professor Matney. I am interested in becoming ULA because I was a LA for CS8W with Professor Mirza over summer, and I found that to be a very exciting experience where I got to see students learn and ask insightful questions. So today I'll be looking at heaps, which is something that is covered in CS24. So let's jump into the whiteboard and take a look. So here we have a max heap, and we're going to be looking at the insert and the delete function. So first, let's check, how do we know it's a max heap? Well, if we look at the first node, or we look at a root node, we see that it is bigger than its two children. So 36 is bigger than 20 and is also bigger than 27. And we also notice that this definition is applied recursively. So 20 is bigger than 10 and is also bigger than 17. And 27 is bigger than 24 and is bigger than 3. So this is a valid max heap. And now suppose we want to insert a node. So let's say we want to insert something. Where will we insert it? Well, we have to first look at the first open position. And we do this by going down the tree and all the way from left to right. And we see that the first level is full, the second level is full, the third level is full, which means we have to insert a node at the fourth level here. Let's insert a node, let's say it's 5 to the left of 10. And now, are we done? No, because we have to check the max heap property, which states that for each node, it is bigger than its two children node. So here is 10 bigger than 5? Well, yes, it is. So this is a valid max heap. But suppose we had a different number that we want to insert, and it was, let's say, 37. We would insert the node to the left of 10, and now we would have to do a bubbling up process, which is a fancy way of saying we'll swap until the max heap property is satisfied again. So let's take a look at this. This 37, it's swapped with 10. This 37 becomes 10. And then are we done? No, because we have to keep swapping until the max heap property is satisfied. So do it again. And we have to do it one more time because we see that 36 is still less than 37. So we will look like this. There we go. So now the max heap property is satisfied and we have a valid max heap. So next up, we'll look at the delete. So what do we do for the delete? Well, we can only delete the top node of the heap. And in this case, it is the maximum element because it's a max heap. If it was a min heap, then this would be the minimum element. So we want to delete the 36. But we can't delete the 36 because this would make the heap fall apart because the 36 has two children. So we can't just get rid of the 36 like that. We would need to do something special. And so what would we need to do? Well, we would swap the 36 with the 3. And so this would become 3 and this would become 36. And so now we can safely remove the 36 without causing the heap to fall apart. And this goes away. So this is no longer here. Cool, but we're not done because once again, we need to make sure the max heap property is satisfied. So starting with 3, which is the node that we swapped up here, we check which one do we swap with? Do we swap with the 20 or the 27? Well, because it's a max heap, we want the bigger number to go up, so we'll swap with the 27. This becomes 3, this becomes 27. Great. Are we done? No, because the 3 is still smaller than the 24, which is this left child. So we do it again. So this becomes 24, this becomes 3. And let's take a look. Do we have a valid max heap? Well, 27 is bigger than 20, and it's also bigger than 24. Good. 20 is bigger than 10, and it's also bigger than 17, which is good. Finally, we check 24 is bigger than 3, and we're done. We have a valid max heap after deleting. And this is how you delete in a max heap. Cool. Yeah, thanks for watching.